They actually existed since about 2007 or 2008 because Vista could do this, but nothing else could. But Vista had so many problems that you didn't want to anger those 6 people that are using Vista. So they just didn't do it at the time. And plus, how much money are you going to make selling these new devices to all 6 of those people? I mean, it's not even going to be worthy. It wasn't until Windows 7 comes out that we have enough of a base for it to matter and do anything. So they started making the modifications for Windows 7, and which again, that was 2009, right? So Windows 7, now we have the ability to start switching drives and getting rid of some of the legacy stuff. So Windows 7 does not have the partition gap. You can now put 2 partitions butt up against each other. They made a decision that we no longer care about cylinder boundaries. We're removing that in Vista. And so from Vista forward, they said, forget about cylinder boundaries. You can have a partition anywhere you want. So if you, before 2007, were trying to do a recovery, and let's say the MBR was gone, you lost the MBR, and you use a tool that searches for partitions, it knows, and it's intelligent enough to know that prior to that date, that it was on cylinder boundaries, and it's almost instantaneous. So if you use a tool and say, search for cylinder boundary, search for my partition, it searches on cylinder boundaries, and it only has like 263 to check. And that's it, and it's over, instantaneous. After that, what happened is all the software asked you a question. It said, is this Vista or later? So if you see that question, there's a reason that they're asking it. If it's Vista or later, it's because no, I cannot check just those 263 locations. I have to check every single sector. If I'm searching for a partition structure now, it can be anywhere on the disk. And then by default, they moved it from sector 63 to 2048. So by default, when you install Windows Vista or later, they moved the location of the partition structure to 2048 as the default. And then you can change it to whatever you want, but that's what the default would have been. Does this make sense to everybody? They did that because GPT needs the first 1,000 for its location for the table, so they moved it further into the disk so that it wouldn't interfere with GPT and the new partition format. Okay? Yes, sir. Oh, yeah, great. Yeah, if you can just put it there, that'd be terrific.
Thank you.
Thank you, sir. Appreciate it. So here's what happens. The new hard drives come out. These are, after 2 terabyte, we could not use anything unless we had 64-bit EFI, and at that point in time we could go past our partition structure, so we can make it larger than 2 terabytes. So you could not have any of the things unless you were booting on 64-bit and you had EFI, and then you would have a hard drive that was larger than 2 terabyte. If you had a 2 terabyte hard drive, anything larger, let's say I had a 3 terabyte hard drive and I want to use it on Windows XP, it will not work because it cannot address it. It cannot work. There are workarounds, there's hacks that people can do to make them work, but strictly speaking, it's 32 bits. So you cannot work on a 3 terabyte hard drive on a 32-bit operating system. So they had to migrate to 64-bit, and then you had to get rid of the BIOS because the BIOS is 32-bit. So they got to EFI. So they've replaced it with an active operating system. EFI is an actual operating system. Has its own processes. It can be alive on its own. It can connect over the internet while the machine's powered off. It can do all kinds of stuff, but it requires EFI and 64-bit in order to use a 3 terabyte or greater than 2 terabyte hard drive. When they went to the 3 terabyte hard drive, this will be the very first time that this happened and nobody even noticed. There is a label here. There is a warning label. It's called an advanced format hard drive. And nobody I know ever read these things. Like, they did not read them to know. Now, hopefully the whole point was at that time, XP was too old, so hopefully it was dead as far as Microsoft was concerned, which we know it's still not. It's still not dead. It's still running. And there's a lot of government operations, maybe submarines. There's a whole bunch of things that are still running on XP or older operating systems. OS2 is still running on most people's voicemail. Most of your voicemail systems and all of the ATMs at one time were all OS2. Some of them still are. So they've been around for a long time. So these drives had a message, and they said, I'm an advanced format hard drive. If you are using Windows XP with a multi-partition and cloning software, you must use WD-Align software. Otherwise, before you've installed your operating system, nobody knew, you must set the jumpers to 7 and 8. So those jumpers force the drive back into its pre-alignment process for partitions. No one knew why this was there. If you read this as a user, you're going to be like, what align what? Why am I aligning anything? You're aligning your partition to a cylinder boundary. That's what's happening. The cylinder boundaries no longer existed, thus forced it to be in a cylinder boundary. Otherwise, it corrupted your files. When you wrote them and you put your partition on there, it would look like it was working fine. And then all of a sudden, a couple hours later, nothing works right. Like it completely strays and starts overlapping sectors that are incorrect because it's reading 4K. These are 4K sectors. So here's what it looks like in real life when you use an advanced format drive. Now remember, all these things I've told you up till now with hard drives, they want to be able to use more space. They're losing the space that they have to all the tracking, to servo information. And if you're a owner of a company that says, hey, why am I losing right now, at least up until the 4K drives existed, how much data do you think, how much space do you think you're losing on every magnetic media to tracking, formatting, servo, whole thing? How much do you think you're losing? What would you think that the approximation of percentage is? What? 20%?
About 30.
Yeah, it's about 30. It's about 30 to 33% you lose. It's a range depending on the manufacturer, but it's between like 27 and 33%. They got to, and what they wanted to, and what they thought was acceptable was 20. That's what they wanted to do. So this is what they decided to do. So in a sector, give me 10, in a sector, let me show you at this point what a real sector looks like. So I did a lot of work to try to figure this out. This is a real sector. What you know as a sector is a figment of the imagination. The Brian Carrier books and things like that, they basically say you have 512 bytes of data, and sometimes they're smart enough to know you have ECC. Well, it turns out it's actually about 591 bytes. It's a fairly large chunk of space that's dedicated directly to every single sector. And in that sector, now servo data does not exist in the sector. It intersects on the drive wherever it is, and it just peels that off. So it's not technically part of the sector, but it is a percentage of the drive. It's actually a pretty good percentage. About 20% of the drive-ish is kind of dedicated to the servo information. Later on, they started embedding it randomly, and they figured out like a random pattern in the track that uses up less space that makes servo information more valuable, which is why now we can separate the two platters. We couldn't do it before because they were aligned with the servo data. That's what it was aligned with. So then, every time you touch a sector, in between every sector, there is sync bytes. And the sync bytes are basically nothing. They are blank space. So the head goes, I don't see anything. Oh, there's a sector. I don't see anything. There's a sector. So you have to have blank space in between for the two sectors to be able to be read. So the head, it's going high, low, high, low, high, low. You're waiting for a blank space so it has a rest. And then you know a new sector is coming. Does that make sense to everybody? So you cannot just keep filling everything with zeros and ones and then expect that it's going to know where anything is. They have to put markers, and they have, some of the markers are just blank space. So you have at least 14 bytes of null. Then you have, all of this is addressing information. Inside the sector, there was originally cylinder location information, which later on basically got replaced with some information in hex and some embedded information. What they later decided, and IBM did this again, they decided, hey, if we have servo information and we know the GPS coordinates of where we're at, why do we need the addressing information? Why don't we just take that out and get rid of it? So they're getting rid of a critical piece of data that is redundant because of the servo data. But if something goes wrong with the servo data, you can no longer find where your data is. Get my point? So we're gradually getting rid of some of the things that we had that would give us some redundancy in the process to save space and use it for something else. Then they actually had cylinders, heads, and sectors, and then again they had a gap. They had more of a gap, so there's more blank space, and then there's ECC to make sure that this data is correct. So you have ECC to tell you that your addressing information is right. Then you had more sync information, and the sync information again gives you just blank space in the sector, and then starts the address marker. Now the address marker is, I'm about to give you data, get ready, go. That's what it says. So I'm out in the field and I'm calling in an airstrike, get ready, go. And that's what it is. It's, I'm going to give you data, it's 512 bytes so you know how much it is, so you know when to stop automatically. There is no random amount of data. It is actually 512 bytes. You read 512 and then you stop. So I'm ready to go. So now the errors that you've been seeing on the deep spars, you've been doing stuff, the ID not found is this part. The AMNF is an M. It's called address marker not found. This is your address marker. So that's the call that you get to say I'm about to give you data. So if it gets AMNF, it already found the ID. But now it does not have enough information, something's wrong here, and it cannot find the address marker. The address marker then says, here's my 512 bytes. And then following that is ECC. And then there's gaps again. There's more gaps in between the sectors. So they're basically sync bytes and dam bytes is what they're called, basically, to try to fit in between things. So ID not found is the I, is the error. Address marker not found is an M on the deep spar. ECC is any of the errors that are involved in ECC, as best I can tell, will just automatically give you an ECC error. Like, I read this, but something's wrong, ECC doesn't match the head stuff, so bam, ECC error. And then it'll usually retry 10 times or something along those lines. The manufacturer chooses how many times it tries. Then if it fails, it's uncorrectable. So you'll get a UNC, and then from there you'll get an abort. So those are the errors for the sector that it's trying to do. So throughout the entire thing. Now those are documented in the book. We'll get back to those, but they're at the beginning of day 2 in the book, basically. And so I've broke down all the definitions for all of those, and I've written them all out. So that, and we'll get back to that. But I just wanted to show you, this is what a sector really looks like. Okay? Now, this is what they decided to tell you it looks like. And this is what it looks like in almost every computer book that you ever see. It's basically going to be, oh look, we've got a sync dam byte right there. Then we've got a gap. This is ECC in their picture. Green is ECC. So 512 bytes must have at least a minimum of 4 bytes of ECC. Some can have more. Some can have, they can't have less than 4. 4 has got to be it. So no matter what you do, if you combine all of the 512s together, you have to combine all of the ECCs together. So you must still have that amount of space. But what they decided to do is if you do that, then you can get rid of all the blank space in between all of the sectors where you have gaps, and you can get rid of some. You still have to have one here and then the next one, and you can get rid of all of these in between. So all the sync dam bytes can go because there's no blank space needed. If the data is all together, I'll just read 4096 and not 512. Everybody good? So that's what it looks like. So they strip that out. They get rid of all the other sync dam bytes. They leave one, and they get rid of all that. And then they just combine all the ECC together for the entire space so that they could try to get more space available on the drive. And so this is what they thought, and this is in their white paper, of what they thought they would get. So they thought originally, again, they always overestimate, that they were going to get actually about 20% of a capacity gain. It turns out to be maybe closer to 11%. So they really did gain some by doing that. You've lost whatever this expanded area would be with the bytes and cut those out, and then increased the amount of size of a single sector into 4K. Now, because they know all the operating systems were not ready for 4K, they logically break it up in the drive. So the drive reads 4K, and it does it in one cycle, reads it into memory. Then it breaks it up into 512 byte sectors and gives it to you in order. Does that make sense? Now, our hardware that's old hardware makes a request for every sector one at a time. So like the original DeepSpar, before this one, that you don't have, made request in hardware directly to the drive 512 bytes at a time. So if it tried to make a request for the sectors, what would happen is it would cause the drive to read that sector 8 times. Even though it already read it into memory, it would be a hardware command and it would force it reread the second chunk. So then it would read the whole 4K, break it up into 512 byte sectors. So very slow and very inefficient on old hardware, whereas Windows and Linux and Macs would all say, hey, we already know about this, so let's just read the 4K and let's just get 4K back. But it's still only delivering 512 bytes logically. So these drives now, again, it's like JAWS 1 and JAWS 2. These drives are now called the 512E drives. It's emulation. So they're called 512s, or 4KE into 512. So you'll see the 512 or you'll see 4KE, but they'll be emulated drives. So they are emulating 512 bytes. And this is becoming a lot of the drives, almost all the drives we have now, are now a 4KE emulated drive with 512 byte emulation. Okay? Everybody good so far? So not a total disaster for us at this point because they are still 512 bytes. But here's your problem. How much do you lose on an old hard drive when a sector goes bad? Some of you have been watching, you've been imaging these drives, and you'll get 1 or 2 sectors next to each other that'll be bad, right? And how much data do you lose? 512. If any part of a 4K sector is bad, what do you lose? All 4K.
A lot.
Yeah, you lose 8 times the data. You lose 8 times the data. I'm telling you, every drive I see that's a 4K drive, when something goes bad, it's a block of 8. You lose the whole block of 8, and it is very difficult to recover from a block of 8. If you lose one sector of 512 bytes in a JPEG, you may not notice it. You lose 4K in a JPEG, holy crap, that's bad news. Right? So that's a very difficult thing to recover from because any error causes an error on 8 times the size. Okay? And there's still not really an easy way to recover. We've lost our ignore ECC command, so you can force it to happen. The DeepSpar can do it, but it's memory, and it's not great. So all the new drives, we have a new command to do this. Now on a DeepSpar, just to show you what the other commands are, the Atola does a lot of this automatically. It already knows it's 64-bit, it expects that to happen, and it's working with all new drives. The DeepSpar is an older machine, so if I hook up a hard drive that is a 4K drive, there is an item here that is gray right now because I do not have a 4K drive hooked up, and it's called long physical sector. Now don't confuse that with long read. Long read is ignore ECC. So you ignore ECC and you can still recover. Long physical sector means I am no longer 512 bytes, I am now a full 4K. And the DeepSpar will do it natively. So now the DeepSpar knows I have a 4K drive, it will be much, much faster to copy. It will not be like, so 1 terabyte will copy 8 times faster as a 4K E drive than it will as a 512 byte drive. 8 times faster. That's a lot. So it really does make a difference in speed and the things that you're doing, but keep in mind what your loss is. So now you will possibly lose more data at a time than you would have otherwise. The second problem is this problem. I don't know how quickly that the PC3000 has updated my version of the PC3000. Then there's 2 new versions since I bought mine. You have to keep spending money. They probably now have an update for long physical sectors, but they treated everything as a logical sector before. So, and there's a reason why they would need to update, because that means the machine's about to become useless, because we're about to head into another drive that's a real problem. Here is why this drive and that label is a real problem if you're using anything prior to Vista. And that is this. So you have a read and the read is 8 sectors. And it needs to start on boundaries. And the boundaries are related to 8 sectors and a physical sector of 0, because now the physical sector is now 8 logical sectors, right? Well, if you can start a partition at any location, then it doesn't make any difference where you pick for that partition for it to begin. But in Windows, it does. It's not a coincidence that it's 8 sectors and that it's 4K, because how big is a cluster? 4K. So in Windows, by default, it is a 4K sector and 4K in one cluster. So one cluster is the equivalent. So when you fill a file, if it was only 2K or up to here, it would only use up to position number 2. The rest of it would be unavailable anyway. This would be slack space that would be just sitting there unused. Does this make sense? So when you write a file, it'll fill, like if it was this big, it would write the first and fill it up. The second one, it would write up to here. As long as it was bigger than 2 individual sectors, it would fill up another cluster. If it's less than 2, then it stores it in the MFT entries. So in other words, if you have a file that is less than 1K, they have a process that's adding attributes together, so your dates and your times, and it tries to see how big your dates and your times and your file name are. And if those things are less than 931 bytes, so in other words, a text file that you just typed some notes in, it's going to be a really small file. That is not going to exist out here in sectors on the hard drive. It's going to only exist in the master file table. And so as part of the table that points to it, in other words, it was more efficient to store the data instead of storing a pointer and putting it out there. Does that make sense? So, do you understand? So that way, I don't use a whole cluster, I only use 2 sectors. And so they are expanding that to 4K. The code's already done, it's already in Windows, and if it is introduced a drive right now that is an actual native 4K drive that is not a emulated 4K drive, it makes it 4K. Do you understand what I'm saying? Not quite sure everybody got what I said. Okay, so this drive is a fake drive, faking out for all your sectors into 512 byte sectors. So when the drive is introduced into Windows now, if this is the drive you introduce, it will still make your MFT entries 2 single sectors. So it is 1024, and the MFT entry points to where the file exists. So you'll have a catalog for your file listing, and it'll be 2 sectors, and it'll point to where the file exists. However, there are new drives that are not emulated. There is now new drives that are just 4K. They no longer emulate 512 bytes. When you introduce it into Windows, Windows already knows it and can already deal with that drive. And when it's installed on that drive, Windows automatically will expand the records that we've had for 40 years, almost 40 years. Those records now will no longer be 2 sectors. They will now be 8 sectors big. If you write a file that now with its attributes is less than 3.9K, it puts it inside the MFT entries. So if it is a tiny file, it no longer goes out and writes them in the other sectors. It now stores them in the MFT entry at 3.9K. Me and Zoran have been testing this. They are in the wild. They are showing up in cases, but very few at this point, because most people don't know what they're buying and what they're doing. So here's the problem. If you're out here and you're in the rest of the world, and this is called a 4K native hard drive, you will now start to see them in the wild. Since 2018, they've definitely been out there in the wild, and I don't care about that. Hard drive. You will now find new drives that are 4K native drives, and they will say that. They'll say 4K in on the top of them. And so I don't know if they've got labels that are good enough that you can see. None of those are showing the label. It actually has a symbol. Like there is a symbol that goes with that shows you the 4K in. These are just other labels. I need to go shopping, I guess, for it. And I bought them and tested them. But this is what it looks like. There'll be a 4K in. There it is. That's it. That's your new sticker. That's what you will see on new drives from now on that do not support emulation mode. And they'll work fine if you plug them into Windows 10. They'll be fine. You won't notice the difference. You'll just be writing data to them and they'll take care of themselves. But you go back to anything else. You pick that drive up and go back to XP or even Vista or something like that, you may have some problems dealing with those drives at all. And if you're using these drives and you just happen to be lucky enough to be doing that, not knowing what's going on, you can easily go back and have used an older machine or done something else and no longer have access to your data or corrupt your data or do something horrible to your data. But on our data recovery software and our forensic software, for 30-something years, we have had 2 sectors equal to where a file is located. That means none of our software runs on the 4KN drive. Axiom dies. Axiom cannot do it. Axiom is more than a year away of writing a new version to fix this problem. The only tool right now I know of that we can use is Xways. Xways is the only one that's updated to handle 4K sectors. None of the other stuff, and it actually builds it and puts it in a list for you. You can see it when you're doing it, and you pull the drive. Xways will note it in its documentation that this is a 4KN drive and that everything is in 4K sectors, including the MFT entries. So it can process the MFT entries. Incase, as far as I know, has not updated to 4K. So none of these other tools will work. They'll all just die. They will not function at all. That also means our data recovery software that we currently have, I do not know of a single one that has updated yet, and I have to double check RStudios because RStudios is usually the fastest at doing these things. So RStudio may have updated to 4KN, and they may be the only one. Nobody else may have done it yet at all. And so, as far as I know yet, I'm sure Apple is taking this under consideration somewhere. I'm sure that this is a part of the new stuff. I have not seen one in the wild. I have not seen a 4K in Mac yet. And I would have to buy a different type of machine because I need to put one of these drives in it. And all of my Macs right now are all laptops. So for running around and doing stuff. So I do not know what the effect of 4KN in Mac's world is right now. But that's our limitation. So that's my next set of tests, is to try to figure out what to do about this. So the cylinder boundary thing affects us here because, again, if I'm writing and reading and a partition can exist anywhere, well, if Windows knows it's 4K, it's always going to create the partition boundary here. But XP and earlier software and equipment does not do that. It creates the partition here. So now what happens is you create a situation with a write and a write, but now you're offsetting it and it wants to read 8 sectors. So when you start it here, it overlaps into another sector because it's more than one read. It actually screws the drive up. It's incredible that they kind of let that happen, but that's what happened. So right now, if I start a sector and a partition here and I say read this, it does an overlap in the read and your data gets corrupt because it's 2 reads instead of 1. So this is what happens after Vista. Vista gets rid of the partition structure existing on a cylinder boundary, and none of our legacy stuff works going backwards anymore. Okay? This is what it looks like for zones on the hard drive. So as you're reading the hard drive, this is a tool that's a Linux tool. It's called Bonnie++. It's a testing tool. It only does numeric values, so you have to plot them in order to get the answer. But as you're reading a hard drive, you can tell from looking at these hard drives, you can see the zones. Now, this isn't a real exact picture of zones. It's not like it pulled the zone tables off and did what PC3000 does and looks at them. This is a logical representation of your zones. And so as you're reading across the hard drive, you can see the outer edge is the fastest and the inner edge is slower. And so sometimes it's slower by a lot. And so for laptop drives, it falls off faster. So the closer you get to the center of the disk, the less speed that you have. And then if you look at this in comparison to a USB device, these are USB hard drives. It's a USB 2 hard drive that I tested. But compared to IDE, where you would have the maximum speed even at the slowest location, USB 2 at least is slower than every hard drive that exists. But here's another thing that you're noticing. You see this? You see these little pluses that are out of the normal realm? Either this is while your machine is multitasking and it's doing 2 or 3 other things, because your drive is the first thing in the interrupt table, it will handle everything from the drive first. If you're doing USB drives and external drives and things like that, they are secondary to the operating system. They run through a driver, and the driver doesn't treat it with the priority. So you'll have a slower speed and possibly bad sectors. And I was told by a manufacturer at one point that the hard drives that they sell in external cases are not the hard drives that they sell to you in OEM boxes to go build a computer, that they use the ones that failed more because they put them in an external case thinking that you couldn't test them as well to know whether or not that they were as good as your OEM drives internally. So you have more bad sectors and they die more rapidly as external hard drives than your internal hard drives. Just so you know, that's how this came out. So, and my tests prove most of the time, I think recently external hard drives have become the premier drive, and nobody's buying a lot of internal drives except OEMs themselves. So I feel like, at least today, maybe they're actually a completely different process at this time for, hang on, she's checking on us for food to make sure. And it is here, so we want to eat it before it gets cold. But okay. All right. For some reason, the hotel told her that the food didn't get here. So, and it's obviously here. So, all right. So, let's go ahead and eat it now while it's still warm. It's a quarter till. So just whenever we're done, we'll just start and finish these things. But I want to get into the GUID tables.